otherwise not, right? We can also, just for here, I want to show you another way uh, of using apply rather than always apply map, is that if we know we only deal with this, what is it? Uh, column here, because typically the entire column is called name, right? So the entire column is string. If the entire column is age or salary or something numerical, then the whole column will have type float or int. And there is no need for us to waste time to scan the first element, is it integer or not, or string. Second element of B, is it integer or string, something like that. So we go by column basis. We go by column basis. And that's why when we say dot apply, lambda, this is basically a series that is being handed to the lambda, the whole column vector. We now check whether the whole column has, because remember in pandas, each data frame is made up of a combination of columns, and each column must have the same data type and the same number of cells as all other columns. So each column can have its own data type. All the cells must have the same data type. Just like here, John, column A is string, column B is float, and so on. But all the columns must have also the same number of cells. And that will make up the data frame. So here, SS is going to be each column, and we use this, a little bit cryptic, but it's there, right? Pandas has an API. API means application programming interface. It stores all the programmatic secrets and nice to have accesses to its internal representation. So it's a very, depending on how you look at it, it's a magic box, it's a secret box, it's a really treasure box to open up. And one part of the API is to deal with types. And we have many questions to ask about type. Is the type string? Is the type numerical? Is the type integer? Integer is a kind of numerical. Is the type floating point specifically? Is the type floating point 64, or integer 32, integer 64? So these are very specific types of integer and floating point, but we don't care. We wonder whether it is numeric or not, which will include long integers, integer 64, short integers, integers 32, floating point 64, all kinds of derivations of numeric types. So is it numerical? All right. So we ask, is this column vector SS numerical? If it is numerical, then sorry, if it is not numerical, then we presume it is string, and that's very safe. Then we perform a ss.string, because all the functions associated with string is parked under .str. So for example, you might find that a series like a here, if we say df8.a will give us a series, right? A series, and we say df8.a.strip strip method. When we run it, it's not there, because the strip is assuming that the series is a string, which is true, but all string commands are parked under .str. All right, just to emphasize that it's string related. That's how Pandas organizes it. Nothing wrong with moving the dot strip right underneath SS. So SS.strip could have been. All right, Pandas didn't do it that way, but it could have been okay. But it would be super confusing, because all the string-oriented calculations, like adding strings, extracting strings, finding string within the string, and so on, will be mixed together with all the rest of the pandas commands, like drop NA, is NA, and all that stuff. So it's very long, very unwieldy, and very confusing. So all the string-related commands, maybe hundreds of them, are parked under .str. All right, just for convenience sake, nothing special about it. So we will strip off, this dot strip is automatically getting rid of the front and back spaces. Very nifty, great to know command to process strings. So I always do dot strip for strings. Now, so when we do this, it is basically making a copy of the space John space and making it John without the spaces, and returning that value back to the lambda. the collar of lambda. But if it is true that it is numeric, right? Because it's numeric of the column. Is it true? Like B like this. Is it true? Yes, true. All right. Then it fails the test because it's not false, right? So then we'll just return the whole column B itself or whole column C itself. So in this case, we are running 4 times only, as opposed to running 4 times 3, 12 times. Now imagine if you have a 5,000 column versus 10,000 row kind of data frame, all right? 10,000, 10,000, 5,000, 10,000. So that's 500 million. 500 million times of running if you do dot apply map versus, right, versus just 5,000 times. So the savings in processing efficiency is tremendous, tremendous if you do dot apply rather than dot apply map. So uh, it is important to start thinking about how to do things, how. So there are a few ways to do things, and they all look the same when the size of the matter is small. But when it grows and scales larger, things look very different. Now, thirdly, we have and this is by no means the last type of error, but it's one big deal here. So errors due to type incompatibility. Yeah. So oftentimes we may be adding values, adding integers to another column that we thought, because when you print out, it looks like floating point or integer, but it is actually stored as string. So when you print it out, Python wouldn't print the double quotes, right? It looks weird that we cannot add 3 to 1.40. Why? Oh, because 1.40 is a string. Oh. So why would that be the case? Because when Panda reads in from the file, sometimes due to NaN, due to space, there's an empty space there that looks like blank, contained in the files. Pandas has no choice but to upgrade the type to the most containing form, the most having the most capacity to hold all kinds of data values. And what's that? That has to be string, right? Because integer cannot hold ABC, but string can hold 123.4 even. So string is the most accommodative data type that is still scalar. And so whenever there's some foreign noise that is unintelligible to pandas, it will upgrade the type to a more accommodative form called string, but that is a disaster to us because we thought we are adding to integer column, but we cannot. So here, how do we detect the type of the column? This is the first question. Here, very simple. Just use the data frame dot d types. Naturally, don't need to ask, is this data type uh, one for each column or one for each row, right? Because definitely it is one for each column. Okay, because data frames are meant to be a sort of a list of columns, never thought of as a list of rows. So here, it will return a series. And of course, you can say, I want the third column's data type. You can always say square bracket 2 to get column C's actual data type, the scalar data type. All right. So we can ask what is the data type of any column or all columns. Then we can check, is the column's data type, like is B's data type, is it a float? Yeah, so we can do this. And Pandas works closely with NumPy, and NumPy supports some derivations of integer and floats. So for example, integer can be 32 bits, can be 64 bits, just think of it as size, how big the integer can be. So likewise, floating point numbers can be 64 bits or even larger, 128 bits, but we just ask, is it floating point 64? So the way to ask is it equal to np dot float 64? So if you have imported numpy as np, this would have been automatically defined, so you can just use it. So this will be how you express your desire to check, is column B a float type? So if it's true, then you feel free to add numerical values, integer values to column B. And this is how we can teach our application Python program to be clever. All right, to deal with column B in a floating point manner, if it is floating point type, or else treat it as a string. What if we want to make sure, all right, make sure column A is a string, make sure column B is an integer, make sure column C is float, D is Boolean. And I'm just trying to, by this sort of business requirement, show you how are the different ways to cast, C-A-S-T, cast the data type of the column into the desired form. All right, so for example, we have these 4 instances. So the way to cast or to force the data type of A into string form is to say df80.a.asType and then bracket string. Notice the string here doesn't have the quotation mark. Actually, even if you accidentally put in the string quotation mark string str, it will still work. So that's how clever or accommodative pandas is, which is nice. It's some people will say it encourages sloppiness, but we are not sloppy, right? We're just following the syntax string. But I didn't know that as type you wanted me to ignore the quotation mark. So I mean, it's debatable. Let's not get into that. We're just trying to say that as type, treat this as a type of string. Yeah, and then we assign back to df80.a because as type wouldn't take in place as a sort of a behavior changer. So we need to store it back. For B, I show you another way to access column B. We can always say dot B, but I'm just trying to show you another way to use the selector of the string B and then put dot as type int. Now you can guess. We can always put as type float, as type boolean, right? Now also I show you some different ways to put on the left hand side. We could put dot b dot c dot d as a sort of a variety. I show you to use the selector of string c, to do this. Can I cross assign? Sure. Can I make c equals to b, but now c is the floating point of b? Sure, you can always say df8 underscore 0 dot b dot as type float and then store into C. So the numbers will be exactly the same, 0.00, 2.00, 1.00. Okay, so the outcome becomes this. Anything that is non-zero gets changed to true. Now here, notice the last cell here in row 2, column D. Had we allowed the noise to propagate further, like 0.00082 down here and then cast it to a type boolean, we would have gotten true, true, and true. Because anything that's off 0, not exactly 0.00, will become true. So this is how dangerous it is. Come down to the sort of sensitive crossover line, the exact point of 0.00. This is where a little bit of noise will change the false to true. All right, and that is magnifying it to the utmost extent. Okay, good. So this is as far as our classroom discussion goes for the 3 main categories of problems, data problems that we want to deal with. Of course, as you expect, in the next video, join me in the lab and we'll just play around with these and see the errors themselves and how to really arrest and incarcerate the problems and the errors. Okay, see you later.